Before I do that, we're going to do a little bit of a back. Yes. Actually, let me do this. I'm going to start with the Sadler method of word problems. And I've used this one back in grade 9. You may have heard this one too if you're in my class. Number one is going to. Sure, you're right. Yeah. Okay. Read each question twice. And the last sentence a third time. Okay. Read the question all the way through here. All right. The reason I want to read the last sentence a third time is that math teachers are lazy on the whole, and I will always ask you, the last sentence will tell you what you're actually looking for. Like, I'll never say, how far is Spider-Man from Venom? Venom is 20 kilometers west and 13 degrees north. I won't give you all the information at the end, right? That's generally how it goes. You're going through that. Number two is dry diagram. Since we're in the trig unit, what is the diagram probably going to look like? Uh-oh. Somebody help me? Good, but no. Triangle, good. Solve any part of the question you can. All right. And number 4 says ask if it makes sense. Ask yourself if it makes sense. Now before you instantly say no, okay, make sure that your diagram, when you're doing it, I've done a lot of trig over the years, and there'll be a question that says Spider-Man is standing on top of a building. Where would Spider-Man be on the triangle then? Probably the top would make sense, okay? Like Spider-Man's not going to be laying on the ground, right? Or a tree falls on a fence. Well, the tree is going to be like this, right? Like you think, ask yourself that, okay? Because I see lots of weird diagrams that are all over the place, all right? Okay, they don't call it the Sadler method, but that's what I use. I'm going to start with 2 dimensions first. You have to know this first. Example 1 says, can I volunteer from the class? Please. Just use your name and a question. Who wants your name and a question? Perfect. Logan. Logan travels from his house. Logan, where do you want to go? Any place in the world? Vegas. Vegas, all right. We'll say 832 kilometers south, 13 degrees west to Vegas. Okay, Logan, where are you going after Vegas? And not straight home, you're going to go someplace else. Let's go Vancouver, fine. Okay. Then 6 south. Then 650 kilometers, we'll say west, 15 degrees north to Vancouver. How far is it from Logan's house to Vancouver? Did you guys do this sort of stuff in grade 10? Yeah, some people did, some people didn't. I'm going to do a recap here. I'd like to leave some space for this question, probably about enough to draw a triangle and do cosine law. Just leave that room. I'm going to do a little recap then if you guys haven't seen this before. Some people have seen this and some people have not. Okay. I'll do a little recap. So this is Logan going from his house to Vegas and then to Vancouver. All right, those are just, I'm not a geography teacher. Okay, so those are estimates for the distance, which are totally off. Yeah, I'm gonna do that right now, okay, because I should have done that first, but I forgot, I assumed everyone would do that in grade 10, which not everyone did. For directions. Georgia, you know that? Okay, so if I do 20 kilometers north, 20 degrees west, what that's going to mean is, here's your start. Okay, let's try again. Yeah, this is underneath, sorry. This example one we're actually going to solve here in a sec. I want to get to, leave a little bit of space for example one, if that makes any sense. Okay, so for the starting point, what the way we draw north 20 degrees west, George's got it right here. You're going to face north. Can I stay with me here, please? You're going to face north, and you're going to rotate west 20 degrees. Now, if you're saying to yourself, which way is west? This is how it's going to go. This looks just like never eat shredded wheat. Okay. The reason mathematicians love geography is where does the north, south, east, west intersect? Like how? Sorry. The origin, yes. What I was hoping people would say is these are all going to be beautiful right angles here. Okay. So between north and east is going to be a right angle triangle, and we're going to use a lot of trick here. For letter B, I'm going to say 126 kilometers east, 40 degrees south. Okay, so can I get somebody that feels brave? So think about how we do this. How would you east 40 degrees south? Yes. Okay, so this is going to be the start. This is going to be right here. Okay, good. Just like you're going east first of all, which is that way. All right, keep going. 40. Yeah, it's 40 degrees south. Okay, so you can see that you're starting east and you're rotating south. On the first one, you're starting north and rotating west. That's going to lead us nicely into our example here. And sorry about that, I didn't realize not everyone's seen that notation before. Do you guys do bearings and all that last year? No. You did. Okay. Forgot I didn't say it. All right. Let's keep going then. So let's go back to our word problem. Does this help clarify things as far as the north, south, east, west? So I hope a little bit. Madison, yes. I'm just asking. You're like you'll tense today, though. That's all. Yeah. All right. Let's put this here. Oh, sure. Where am I going here? That's what I want. Okay, so let's go through here. So it says Logan travels from south 832 kilometers south 13 degrees west. So I'm going to draw this diagram as nicely as I can. So what's the starting point for this diagram? It's going to be what? Where's the starting point? Logan's house. Let's call that L. So I'm going to put a point right here, and I'm going to call that L. How am I going to draw south 13 degrees west? Go ahead. Yeah. So there's your south arrow. 13 degrees west, which is going to be left. And that's going to be 832. Where's the second dot go to? What's the dot at the bottom letter B? Yeah.
What's the 832? Is that just how long?
That's the distance. Yeah, that's the distance. Right? Because it just
like dot to dot?
the 832. Yeah, goes from here to here. That's the 832. What's the bottom dot going to be called? Vegas. So the all that. Yeah, there's Vegas and Vancouver. LV. Logan, Las Vegas, and Vancouver. What was I thinking? Okay. Wasn't good. Okay, as far as the next part here, how do I draw west 15 degrees north? Someone new here, please. How do you draw west 15 degrees north? Go ahead, Andrew. Okay. Good. Is that a 15? I'm calling that a 15. I'm calling that, okay? So we're gonna go here this way, that's west. And that's gonna be Vancouver, and that's gonna be 15 degrees. What are we actually looking for? Oh, sorry, that should be 650 kilometers. What are we actually looking for in this triangle? It should be a triangle. Yeah, you're looking from Vancouver to Logan's house, okay? All right, so here's the difficulty in this question. Does anyone see any problems with my triangle? Yes. Yeah, I have no interior angles at all. Okay. What angle are we going to need to find?
Find the angle of Los Angeles.
Yeah, this is the one we have to find. Very good. This is the one we're going to have to find. Can anyone give me any ideas of how I can find it in between angles? You're going to need that. Yes. Okay, good. Okay, so this is going to be, I'm going to do this in two parts here, okay, because there's a few different ways you can do this. This right here is going to be 75. Just that part, right? Because if you have 15 degrees here, up to here it'll be 75. All right. How do I get this, the other side of the 75? It's going to be 13. How's it going to be 13, Riley? Have you ever said that? Yeah, the Z pattern, okay? So 13. If you don't like Z patterns, if you say to yourself, Mr. Sadler, I hated that, you're in grade 9. Okay, the other thing you can do is make another triangle down here and call that 77. Right, because that's a right angle, and do all your thing. Or the same thing for a right, a whole line is 180. So the middle one's going to be 180 minus the two other side lines. So there's many different ways to do it. I, of course, am going to redraw this triangle because I like neatness. So here's my X. My angle here is going to be 88. Is that right? So confirm that. It's 8, right? 88 and 832. Is this looking okay? Did I make a mistake? Taylor, let's come back.
I should have covered this for grade 10.
See, grade 10. Grade 10. I know Mr. Walter does it. Okay, here we go. So, how do I solve for X?
Did you do the sine law or the cosine to cross thing?
Yeah, which one would be sine law, cosine law?
Right.
Which one is it, sine law or cosine law?
Cosine?
It is cosine law, okay? Now, I would love to use sine law. Now, here we told the joke that I had a needle teacher named Mr. Lacey who would give me a question like this. Sine law is nice because if you need opposites, so right. So 650 is opposite this top angle where there's nothing. 832 is opposite the left angle where there's nothing. So I don't have enough opposites to sine law. So I have to use cosine law. Can someone recite cosine law from memory, please, for me? Nice and brave. Oh, but you got a hand raised. No one else? Brooke, I'm picking on you. What's cosine law, please?
Jason.
Cosine law. Cosine law.
Oh, is it big C over
Help her. Somebody help her. Who's that? Who's that?
how about
Oh goodness, oh my goodness. All right.
A squared plus B squared minus A. Yes.
Is this coming back? I hope. I use C squared normally, but I was helping somebody, I don't know if it was this class from my 3M, and they wanted A to be on the left instead of C, so that's where I do small. All right, now what are the two important sides for this? Go ahead.
Important side.
Yeah.
The distances to Las Vegas and Vancouver.
Good, yes, okay. But as far as this goes here, I don't know which side's A. What side's going to be A here?
Okay.
Why? Why?
That's what I'm trying to find.
Yeah. Right? Well, no, we're not just, that's what they're trying to find, no. It's, yeah, because you have the angle, okay? It does happen to be this one you happen to find, but you need to have angle A is going to be across from side A, right? So if side A is X, angle A is going to be 88. So I'm going to type in here being right, X squared equals 650 squared plus 832 squared minus 2 times 650 times 832 cos 88. Do you guys all have super count computers that can do that in one step? I hope super calculators. I hope. If you don't have a calculator with you today, we will need to get to the third dimension, all right, because, you know, you need a calculator. You know, I have them for sale for $10.
I think you still owe me $10.
I gave,
I don't think so.
I did pay that.
Maybe I'll just eat this one. You know, the
Alright, so if we start with the calculator too, Alright, anyone work out with x squared is equal to? When I say anyone, I mean everyone, so you should do it all the way through. 650 squared, 832 squared minus 2 times 650 times 832 times cos 88. I'm so excited for the third dimension, I want to keep going here. Okay, if you're waiting for me. I got 107,6,976. Okay, then we'll square root that, and we should get 1,037.77. Okay, there is a question on the choice assignment that's 2 dimensions like this. Okay, there is a nice 2-dimensional one that's like number 5 or 6 or something. There's a nice one like this. Do you see it there? Do you know the number there, Madison?
Those 5 dimensions is that?
No, not that one. The one above that. The word above that. Well,
The travel, yeah.
yeah. So that's number. This is like number 4. This one would be. Okay. On the choice assignment. Yes.
This answer doesn't make sense. That's the one I'm talking about.
What's that?
That answer doesn't make sense. And you said the answer has to make sense. You have to ask yourself if it makes sense.
Well, we're going to assume that Logan's house is in South Dakota or something like that. Is what he's going to be.
Well, how is he here? That doesn't make sense.
I don't know his living arrangements. Okay, how that works.
Cultural is not working.
Yeah, but the thing is, remember, the only thing that's connected to cosine is this, right? Okay, I'm going to hit pause in the video, and then I'm going to start with the third dimension. 8